prove that fg dash is equal to f dash g plus fg dash. So it's a product rule. To prove it, so you consider this f plus g whole square. Now you differentiate this f plus g whole square using the power rule, that is f plus g whole square dash. If you differentiate it, then what you get by power rule, 2 times f plus g. By chain rule, differentiation of f is f dash, differentiation of g is g dash. Now open the bracket, then f dash plus f g dash plus g f dash plus g g dash. So give this to number 1. Now what you do is, again you take f plus g whole square. Now you expand f plus g whole square, then you differentiate. That is f plus g whole square, if you expand, then this is f square plus g square plus 2fg dash. Now if you differentiate, then differentiation of f square, that is 2f f dash by chain rule. Similarly 2gg dash plus 2fg whole dash. So this is equals to, if you take out 2 common, 2ff dash plus gg dash plus fg whole dash. Give this number 2. Now what you do is, now compare the above 2 expansions, that is 1 and 2. So left hand side is same. So if you compare one and 2, then what you get here, 2 cancel, then from first one ff dash plus fg dash plus gf dash plus gg dash is equal to second one ff dash plus gg dash plus fg whole dash. Now from both here from here ff dash cancel, and gg dash cancel. Then you left with fg dash plus gf dash is equal to fg whole dash. That implies fg whole dash is equals to fg dash plus gf dash, hence proved. So this is the proof of the above result, that is fg dash is equal to f dash g plus gf dash, that is the product rule.